So up to now, we have shown you a variety of basics of Java programming, namely assignments, if statements, or even nested if statements. However, even with just these basic constructs you can write for your program can already go beyond what you can actually manually trace. So you really need some nice tool, like how I did on my iPad usually to illustrate how the program works. You need something to also help you to do the similar kind of analysis of your program. When your program gets complicated, you just need a systematic tool to help you. And that's why in this tutorial video, we would like to show you a very powerful tool that professional programmers use in order to really find defects or failures of their program. It is called Debugger in Eclipse. So that's something I would like to show you for this tutorial video. What I will do is I will show you maybe as, first of all, I'll show you what the debugger is conceptually, and then I will revisit one of the swap program we did previously to show you how the debugger can work. And then I will try to show you a program with the if statements and show you how the debugger can be used to trace the program execution when you pass the various inputs to the your program. And later on, when I talk about loops or other control structure or even classes and objects, I'm going to assume you have some reasonable grasp of the debugger, so we can always use the debugger to analyze your programs. That's kind of the techniques I would like you to build from now on. Okay, so now let's first create a project for your lab number 2, and we'll do a very simple program just to learn how to use the debugger from the basics. Okay, let's create assuming that you're now in your CS1022 lab workspace repository, let's say, and then you can say File, New, Java Projects. Okay, let's create a new project called Lab 2. Okay, and then under Lab 2, let's create a new class just to begin with. Okay, you can right click and say New, and then Class. Okay, we're gonna use this program to illustrate debugger. That's our very first program. So let's call that debugger. Okay, debug, you can see that's how you spell debug, which means to get rid of bug, and debugger. Okay, and then let's say swap program, just say swap. Okay, let's have a main method over there, and then we say finish. Okay, so that's the program we have. Let's first of all, what I would do is I'm gonna ask you to actually do a swap program for me. Okay, so we learned about how to do it, but I'm gonna just write it out. Okay, let's say without any user input and output. We'll do the user input and output maybe in the next example. But for this one, let's keep it really the simplest possible. Let's say integer x is assigned to, let's say 10. And then we got integer y is assigned to, let's say 20. So we got two variables over here, both integers. And let's say we want to do a swap so that x becomes y and y becomes x. Okay. Before we do that, let's simply say system.out.println, and then we can say x is, okay, over here we got x, and let me just copy this line here, and then I can say y is, and then y. Okay, and now let's say we simply want to do a swap. Let's do it naively, which is wrong. If I simply say x is reassigned to y, and then y is reassigned to x. Apparently this is wrong. I knew it because we needed some intermediate variable in order to do it. But let's say we simply don't know. Okay, that's what we thought would be correct. Okay, and then I simply just copy these two lines over here, and we got x and y over here. Okay, so now we got 10 and 20. So we expect to see x is 10, y is 20, and what do we expect to see if the swap was succeeded? If we succeeded, we should really expect to see x is 20 and y is 10. However, it is not going to be the case. Let's see. So if I simply just go back to the package explorer, and then I can right click on debugger swap class, and then say run as Java application. Let's see what happened. Okay, you can see that before the swap, we say x is 10, y is 20. After the swap, after what we thought would be correct to be the swap, x is 20 and y is 20. Apparently the swap was failing. Okay, so now what we would like to do is to see exactly how things go wrong. So of course this is a very simple example. You can simply inspect the program by your eyes. You can easily tell the mistake possibly. Okay, however, I would like you to really take this opportunity opportunity to really see a general pattern over here. Whenever you try to have a block of code developed in Java, however, it simply doesn't do what you expect it to do. In which case, it will be very difficult for you to just look at the lines of code you have written, which might be hundreds or even thousands lines of code. In that case, you really want to say, I want to slow down the sequential execution of the line of code over here. So rather than giving me the final output right away, I want you to show me how each line of code is executed, so I can see exactly how the variables and how the expressions have changed their values, so that I can see exactly what's wrong. Okay, that's a very general pattern over here for problem solving. That's why at this point you deserve to learn this advanced technique. Okay, let me just show you exactly how things will work, just so you get hands-on experience, and then I'll explain in the iPad how it works in general. Okay, so now let's do the following. You can see that along the lines of code over here on the editor, you can see there's a blue bar over here, right? You can see there's a blue bar starting from line number 4 until roughly line number 14. There's a blue bar, right? So now I would like you to simply see the following. These are the lines of code for our main method. And I would like to say the next time when I try to really execute the lines of code in my main method, I would like to pause the execution at the first line, which is line number 5. How do I do it? You can see go to the left of line number 5, simply double click on the blue area. You can see there is a point over here, it's called a breakpoint. Okay, so what we are trying to say is next time, if we choose to actually debug our program, let me just disable this. If we choose to debug our program, we can simply put a breakpoint. You can put a breakpoint anywhere in your program, but typically you might just put it at line 1 of your program. I put it there, and then I can simply say now next time I want to debug my program as a Java application, and the execution is simply just going to pause at line number 5, and then I can really execute my Java code line after another line at my discretion, at my own pace. Okay, so that's kind of the idea. Let's just try to get used to it, just for the very simplest program possible. Okay. After we have set up the breakpoint over here, you can set just one, and when you get more experience, you can definitely set up more than one breakpoints. It's completely up to you. Okay, so now what I would do is now you can right click on the same class over here. Rather than saying run as Java application, you're gonna say debug as. Okay, basically what debug as Java application would do is it's going to pause at every breakpoint that you have set up. And then you can, from the breakpoint that it pauses, you can actually say, now I want to execute maybe one line at a time. So it doesn't really go all the way to the bottom of your program, right? Remember, usually without a breakpoint, you will simply starting from line number 1 and go all the way very fast to line number 13 and tell you what the answer is. So that's why you see the console output so quickly. But this is not very useful to you when things go wrong. When things go wrong, you really want the execution to pause somewhere in your program so you can see exactly what has happened on the way to actually generating the final output. That's kind of the idea for debugger. Okay, so now let's try that. Right click on this Java class over here, and then you say debug as Java application. Okay, and then as soon as they say that, okay, you don't have to worry about the red error message over here. It's only for my computer. Maybe for yours it's the same, but you don't have to worry. It's still working. Okay, so now for the very first time, confirm perspective switch. Remember in the previous video we talked about Java perspective, which is you got editor, you got package explorer, you got outline view, you got console, you got problems, right? So these are the panels you can set up for your Java perspective, namely the stage where you're trying to compile your program, where you're trying to develop your program. So now, when you're trying to debug your program, there is another perspective called the debugging perspective. So for the very first time, you simply ask you if you want to switch to the debugger perspective. Yes, let's say we want. You can either say remember my decision, so it's not going to bother you with this pop-up menu anymore. Okay, you can say switch. Okay, as soon as you say switch, it's going to show you a slightly different view as in the Java perspective. Let me show you one thing first. You can see around the top right corner over here, you can see that there's a bug button over here. If you move your mouse over, it says debug. So this is the debug perspective that's currently being chosen. You can easily switch back to your developments Java development's Java perspective, you can see right to the left of the debug button there's something called Java. So that is the Java perspective. If you click on that, so this is where you were. Okay, so you can easily switch back and forth. But I would say if you're still debugging your program, you should really always keep yourself in the debug perspective. Okay, but you can easily switch back and forth. So now you can see that this line number 5 over here is being highlighted. So that means now the execution started, however, it paused at line number 5, exactly where we set up the breakpoint, right? So that means at this point, where are we now? We are now at a point right before we try to execute this particular line. So that means at the moment, we are now even before we try to declare variable x with initial value 10, even before that. So nothing has been declared just yet. Okay, so now how do we see this kind of stuff? So there are two things that's really important that can help you. Okay, let's just try to see how they work. So now I would like to draw your attention to two panels. We can try to drag and drop them to the comfortable place. One is called variables over here. Okay, you can see the variables here. In case you don't see it easy, you can see. Let me just close them. Okay, if in case you don't see variables, another one is called expressions. In case you don't see expressions, I also show you how you can find them. Okay, you just simply go to Window and go to Show View, and over here, for example, you can see the variables over here. Okay, that's how you find the variables. If I click on that. So now I have the variables over here, right? I can simply drag and drop. My personal preference would be simply put them at the bottom here, right? You can just drag them, let's say, right beside the console. Okay, that's the variables over here. Okay, variables. The other one you need, that's also very useful, is called expression. You can also go to Window and Show View, and then you can go to expression. Okay, let me show you expressions over here, right? One is variables, the other one is expressions. If you click on that, so now expressions here, but I can left click, hold it, and then drag it to maybe right beside the variables over here. Okay, and now you can see variables. We got expressions at the same level as a console. Okay, that's just my personal preference. You can drag them to different places if you prefer. Okay. For the breakpoints, it simply show you the breakpoints you have done so far. Okay, for that one you can keep it, but I will just drag and drop to here. Just make it a little bit easier for me to read. Okay, so now this is, you can think about this editor over here is highlighting the line that's being currently paused at, which means right before. So now we are at the point that right before we try to execute this line. So now I want you to pay attention to the variables over here. Let's understand the variables first. So now let's expect something here. What do we expect to see after executing this particular line over here? Well, as according to what we learned before, it's going to declare a variable x with the initial value 10, right? So now I want you to look at, there are two buttons over here, okay? You can see, especially I want to look at this one only. Oh, by the way, this square button here simply means terminates. At the moment, you can see that the terminate is enabled, which means we have not terminated yet, okay? If you just want to stop the debugger right away, you can definitely click on the stop button here to terminate. Okay, but let's say we don't want to do it. For the moment, the only button you have to worry about is this one is called step into. You don't have to worry. We only worry about it after the reading week once we talk about the methods, but we don't have to worry about it for now. Look at the one that's besides that. It's called step over. Step over basically means because we are pausing at the moment right before we try to execute line number 5, let's try to execute only that line. That means step over. Step over to line number 6. Step over to the point right before we try to execute line number 6, right? So just execute one line only. If I click on step over here, let's expect what's going to happen. Basically, you're going to see that in the variables panel over here, at the moment, there's no variable over here. But as soon as we say step over, which will execute line number 5, we're going to see exactly one variable over here called x with the value 10, right? That's how I would draw in the iPad illustration to you previously. Let's try that. If I say step over, click on that, what you will see is you can see exactly this x over here. You can see x, the variable that we just because we just executed line number 5, but we have not executed line number 6 just yet. So that's why y is not there yet. Okay, so now x is declared with initial value 10. Okay, you can see the name over here. It's very easy to understand. Only 2 columns to understand. The left column is the name, which is x, and also value is 10. But if you click on the row over here, it also show you the 10 is the value for x. You can also move your mouse over x. It also shows you that the value is 10. Okay, it might change, of course, because we think about the variable as a box, and then every time if you reassign to the variable, it might change the value in the box. That's exactly what we're going to see. Okay, okay. So now let's do another exercise here. So you can see that now line number 6 is now being highlighted, and there's an arrow over here. This is the flow of execution. Okay, you can see the little arrow to the left of the line number 6 over here. So now we are at a point right before we try to execute line number 6. So that means x has been declared true. However, y has not been declared just yet. Okay, so now if you say step over again, what do we expect to see? Well, we expect to see that y will be declared as one of the variables over here in this variable panel, and also y will be assigned to initially 20. Let's see if that will be the case, right? Basically, every time when you're using debugger, you always have to look at which line you're trying to execute. For example, in this case, line number 6. And also think about what do you anticipate to happen. What you think will happen sometimes may not be exactly what's going to happen. In that case, if you have such mismatch between what you expect and what actually happened, that means there might be some issue with your program. Okay, that's why debugger is so useful, because you can easily find the bugs by yourself, even for complicated program. Okay, so now let's see this. If I say step over again, you can see now we got another variable over here, y, with the value 20, right? So far so good. So now we are now at the point right before we try to execute line number 7. So now let's try to predict what's going to happen. You can see this is a string literal over here, and this is a variable. And what's the value for x? Well, you can either look up x value from the variables panel over here. You can see x and then 10. Or there are 3 ways of doing this. I'll show you all the ways. Either you can see under variables x, and then you can see 10. Or you can simply go to expressions. Basically, you can put in any expressions, either integer expression, Boolean expression, or number expression, doesn't matter. Any expression that would make sense in the current scope. As long as you refer to variables that the current scope can allow, that will be okay. For example, add new expression, I can simply put x, right? X is just an expression for integer. If I say that, it tells me x is simply 10. Well, you can do actually more. The advantage for the expressions panel is you can put in any expression to actually see how they will evaluate into, right? I can even say 2x, okay? That will give me, oh, sorry, let me do it again. I mean 2 times x. I can say 2 multiplied by x. Well, it's going to give me 20, right? I can even try, let's say x modulo 3, for example, right? That will give me 1, right? Because x is 10, modulo 3 will give me 1, right? You can do as many expressions as you like if you find necessary to help you understand the behavior of your program. Okay, I'll try to show you more, but hopefully you can also try to practice that yourself. And okay, approach number 1, look from the variables panel. Approach number 2, you can type it out in the expressions panel. And approach number 3, you can simply move your mouse over x over here. It will also show you 10. So that means it's going to be x is 10. Well, that's kind of what we expect because we initialize x to be 10. So far, so good. So now if I say step over here, and then you can see that from the console over here, this first line we output to the console is x is 10, right? So now you can see we can even predict what's going to happen before it actually happens in the console, or even before it happens in the variable reassignment. So hopefully you can gradually see the value for using debugger. You can really try to slow down the execution for the program so that you can see for each line, what do I expect to happen? And then what actually happened, and compare the both, okay? So now what do we expect to see from this line here? Well, so now we are pausing at line number 8 right before we try to execute this line over here, right? So let's see y is what? I use approach number 3, I move my mouse over y, it should be 20, right? You can also try the variables and also try the expression. I'll leave that to you. Okay, it's easy to do. And then I can simply say step over again. Okay, if I say that, you can see now I've printed y is 20. Okay, that's good. So far so good. So far so good. It's before the swap. I got x being 10 and y being 20. So now how do I actually try to see the swap? So now here's a critical thing. Let's say I didn't know what went wrong. I simply knew that when I try to execute a program without a breakpoint, it simply tell me after the swap x is 20 and y is 20. Apparently that's not the correct behavior for a swap program. So now let's try to see exactly what's going to happen here. So now at this point over here, where you can see line number 10 is being highlighted, and you can see the arrow over here telling me the current execution flow is right at this point, right before I try to execute line number 10. So now, what do I expect to see? I'm trying to see x should be reassigned to y, right? So now I know that x is 10 and y is simply 20, right? So now I should expect to see after this, x should become y, which is 20, and y should remain to be its old value, which is also 20. That's what I expect to see, right? It's kind of like a halfway through the swap. Okay, so now what I can do is I can simply say, oh, let me just, you can just go back to the variables over here. I want you to watch, okay, x and y over here. Okay, just watch when you're watching the recording, see how x and y will change. Specifically, x is going to change, right? If I click on step over, you can see that x has become 20 and y has not changed. Okay, so now we are at the point right before executing line number 11. So now, because we're kind of expecting the other half of the swap to really swap y to x, right? That's why we are doing this particular reassignment over here. So we say y is assigned to x. But now, after y is assigned to x, we might expect maybe y to become the value of x, which should be 10. But however, this is not going to be the case, right? Because it's the wrong version. So what we can do is, maybe in the debugger, you can simply go to expressions over here. You can see one of the expression we put was x is actually 20 rather than 10. So x value has already been overwritten by the value of y. So we can no longer get access to the old value for x. So at this point, we can actually find out there's something wrong with our program over here. Because when we are trying to do this particular reassignment for y is assigned to x, the value in x is no longer the x that we thought about, right? We were thinking about the x value over here to do the swap, but x value has already been overwritten in the previous step, so it's now actually 20, which is not really what we wanted, right? Okay, that's kind of just one example analysis for you. What you need to do is really try to do the analysis yourself for the own example you're dealing with, right? I can do another one with you, okay? So now what we can see is, now what do we expect to happen? So what we expect to happen is, now you can see that as soon as we execute this line, number 11 here, by saying step over, y would be overwritten by the value for x. At the moment, x is simply just 20. Now, y overwritten by 20, well, doesn't change because y is already 20, right? Just itself. So now if I say step over, you can see that now x and y both are just 20. This is why when you try to step over to execute line number 12 and line number 13, you will simply get x is, well, x value, which is 20 over here, and also y is the value for y, which is also 20. So that tells us the swap was not really done properly. Okay, if you try that, okay, try that. Line number 12 is going to tell you x is 20. Okay, that's already, x is 20 is fine. However, when it says that y is also 20, this is where it went wrong. Okay, but as we actually look at each line execution really smoothly, very slowly, so we knew that there's something wrong when we were trying to do this particular assignments over here, especially on the in the second half, right? So that's kind of the advantage for debugger. Hopefully you get an idea, right? So now how do we change it? Okay, let me show you how you can change it and do a debugger very quickly with you, and then we do another example. Okay, so now let me stop this. Okay, once I stop, so now I'm still in the debug perspective. Now I should really switch back to the Java perspective to make some change. So now you can go over to J over here. You can see Java over here, right, on the top right. Click on that. So now we are back to Java code, right? So now we knew how to fix this. Let's fix it, for the sake of illustration. I can say integer, and then let's say what I would do is, let me do the following. I can say integer, some temp variable is assigned to x, right? We're going to capture the old value for x. And then x is assigned to y, and y should be assigned to temp. This would be the correct version for the swap. So now we would like to see exactly how this can be illustrated, right? You can see the program itself is easy, but I think that there are many ideas we are learning new over here, which is about how we can really set a breakpoints, how we can execute line by line by using step over, and also for each line, how you can see the variables and also expressions panel in the debug perspective. It's really important for you to get used to this kind of mindset. It's new, but it will be very, very pay off later for a complicated example. Okay, of course, if you are stuck in, for your methods in the lab test, you can definitely use this as well to help to save yourself. Okay, let's now do some program very quickly. So now what I want to speed up a little bit. So let's say I don't really want my execution to start from line number 5. I want to start speed up because I pretty much know the problems occur starting from here. So what I will do is you can see the circle over here, the breakpoint. Double click on that, and it's gone, right? So that means at the moment there's no breakpoint anymore. I would like to start with line number 10. So right beside line number 10, double click. So this is the breakpoint I have, right? So now if I say debug as Java application is going to pause at line number 10 right before we try to execute line number 10. Okay, let's do it. So now I can right click on the debugger swap, debug as Java application, right? Make sure you choose debug rather than run. If you simply say run, it's going to skip all the breakpoints, but you gotta say debug. If I say debug as Java application, so now we are switched automatically to the debug perspective over here, right? You can easily switch back to Java perspective as I show you. Okay, so now we're in line number 10. If you can see so far we have already printed out the first 2 lines from over here, right? We have already done that. So these 2 lines have been executed without pausing because the breakpoint only started from line number 10, right? All the lines previously have been executed already. Okay. So now let's look at the variables panel over here. You can see at the moment x is 10 and y is 20. That makes sense from these 2 lines over here, right? So now let's predict what's going to happen after we try to execute line number 10. Well, it's going to create a new variable called temp with the value the same as x, which is 10. That's what we expect to see, right? That's exactly how I illustrated on the iPad with you in the earlier tutorial video. Now we can see everything on Eclipse, right? More importantly, now you don't have to rely on me. You can rely on the Eclipse to tell you exactly what's going on. Okay, so now let's see this. As soon as I say, you can also, of course, go to expressions. You can also type maybe temp. If you say temp over here, at the moment, you can see temp simply say error during the evaluation, simply because now we are right before executing line number 10, which means temp does not exist just yet. Temp will only exist after executing line number 10. Okay, that's something for you to notice. Okay, so now if I say step over here, now you can see that now temp becomes 10. Okay, you can see 10 over here. Also, you go back to variables, you can see the temp variable is over here is 10. Okay, so temp is storing the old value for x. So now, after line number 11, we're going to override x by the value of y. Okay, however, the old value for x will still be here. Okay, so now if you try that now, I want you to pay attention to the temp and x, right? At the moment, they're simply just 10 and 10. What do we expect to see? We expect to see 20 and then 10, right? That's what we expect to see. And then you can simply say step over. So now you can see that now we got 20. Sometimes, very often, Eclipse also show you on highlighted yellow, which tells only the variables value highlighted yellow has been changed. Okay, so now we got 20 for x and also 10 for 10. Okay, that's good. So now what do we expect to see after the last line? The last line, we simply say y is assigned to temp, and temp at the moment is storing the old value, the initial value for x over here. So that's correct, right? If we say step over again, you can see that what's changed was y, and y has now become 10. So you can see 20 versus 10. That's exactly the kind of swap we are expecting. So this version of the program is working correctly. But thinking this way, in general, you may end up with an incorrect program to begin with, in which case you have no idea how to fix the bug, how to fix the error. Rather than asking the TA, rather than asking the instructor, what you should do is you should set the breakpoints at the first line of your program and try to really look at each line at the variables and also the expressions panel to see if things happening over there matches what you expect to happen. As soon as you see anything that doesn't really match your expectation, there's something wrong of your program, in which case you can fix it and try to execute the program again and to see if that will produce the output. That's a very useful solution pattern for you to actually debug. Okay, so now you can see that X and Y. So now X, if you move your mouse over, X will be 20, correct? And also Y will be 10. Okay, we can predict even before we try to execute the console printout. Okay, now you can see now X is 20. Okay, we have just executed line number 14. Let's execute line number 15. It will say Y is 10. Okay, so now the swap program is now correct. So now I really want you to practice how to go from the incorrect version using debugger to the correct version using debugger. It's really important for you to grasp this technique. Okay, I would like to show you one more thing about if statements very quickly. Okay, and then we are done with this, and then we can show you the more advanced concept about loops. Okay, and then we can assume you got some basic knowledge about debugger, and then we can keep exposing you to the debugger, for all the control structure. Okay, let's terminate over here. I can simply say terminates, and then you can go back to the Java perspective over here. Okay, now let me create a new class over here. If you right click on Lab 2 projects, and then you can say new, and then you can say class over here. Okay, let's call it debugger. Okay, if statements. Okay, and then we can do the main method over here. Okay, you can say finish. Okay, so over here I'm gonna really show you some maybe input and output a little bit with the if statement, but I'll just show you some input values for you to get an idea. I'll leave some values for you as an exercise. Okay, so now let's say we declare our scanner. Okay, scanner, and then input is new scanner, and system.in from the keyboard, and always the last line should be input.close. Okay, let's say we're only reading one integer. Okay, let's say integer x is assigned to input.next int, and then let's say based on the input x, it can be positive or negative, or it can be larger than 10 or between 5 and 10, so something like that. And then we can print out different messages. Okay, let's see what's going to happen. We can say if x is less than 0, okay, and then we're going to say system.out.println. Okay, here we can say x is negative. Else if, okay, now we can say that, let's say else, which means implicitly x should be larger than or equal to 0, right? If we can reach the else part, that means the if condition is simply just false. Okay, so now if x is larger than or equal to 0, let's say x is in between, let's say 5 and 10. Okay, let's say 5 is less than or equal to x, and x is less than or equal to 10. In that case, we're going to print out system.out.println. Let's say x is between 5 and 10. And then else over here, else part, which means x is not within this particular range, right? It can be strictly less than 5, or x is strictly larger than 10. Okay, x is strictly less than 5, or x is strictly larger than 10. And then we can say system.out.println. X is smaller than 5, or x is larger than 10. A very simple program for us to manipulate. Okay, so now let me try. Apparently you can see we got 3 possible outcomes. Either this over here, line number 11, or this at line number 15, or this at line number 18. So what I would do is, let me try that without setting the breakpoints in debugger and try to see if we can exercise these 3 branches. And then we're going to see the debugger, okay, and see what happened. Okay. So now if I simply just go back to the package explorer, and then I will right click on debugger if statements and say run as Java application. Okay, if I do that, oh, one thing I forgot. Can I just stop it for now? Okay, if you click on terminates over here, okay, let's prompt the user. Okay, so that'll be a little bit better. Otherwise, it still work, but you know, it'd be nicer if we always prompt system.out.println. We can say enter an integer. Okay, just put it there right before we try to read in. Okay, let's execute the program again. Okay, enter an integer over here. For example, we can say -2. And then it would say x is negative. You can see the program has terminated. That's why the stop button here is disabled. Okay, let's try another one. If x is in between 5 and 10, let's say 7. And then it would say x is in between 5 and 10. And we knew this particular branch was executed, but we're going to verify that using the debugger. Okay. And now let's try another one. Let's say x is either smaller than 5 or larger than 10. Let's say 15, for example. So that is not in between 5 and 10. In that case, it would say smaller than 5 or larger than 10, right? Very easy. So now I would like to show you now how exactly to use the debugger in the context of the if statements. And once we introduce you the idea about loops or objects, you use the same idea over here. But I'll gradually I'll keep showing you the debugger. It's really powerful concept. If you want to become a professional programmer, software engineer, or just a competent programmer, this is really something you have to get used to and try to practice yourself. Okay. So now what I will do is I'll simply just put a breakpoint. Okay. Let's say I put a breakpoint over here. Okay, which means we will switch to the debugger perspective as soon as we actually initialize x to be some keyboard input. Could be any of the numbers that we just enter, right? Okay, let's see exactly what's going to happen, right? So I put a breakpoint at line number 11. So we can expect that as soon as we execute, as soon as we reach the point right before we try to execute line number 11, we're going to switch from Java to debugger perspective. Okay, that's what we can expect. So now right click on the same class over here, debugger if statements, and now you say debug as Java application. Okay, you say that. Okay, so now we have not switched to debugger perspective just yet because we are still at this point over here, right? We haven't really reached there. Okay, so now enter integer. Let's say we do the first one. If I say -4, okay, so now that means as soon as I hit enter, so this line will be executed, and once this is executed, it's going to be pause at line number 11. At the same time, it will switch to the debug perspective. Okay. Okay, that's exactly what happened. So now you can see that now we are in the debug perspective over here, right? So now we are at the point right before we try to execute line number 11. So now let's look at variables over here. If you look at the variable, it's -4. But now we want to know which branch will be executed. So now you can easily go to expressions over here, right? So these are from the previous execution, right? The previous example, you can just select them all and right click and say remove all. Okay, so we don't need them. So you can always refresh the expressions for each application you are trying to debug. Okay. So now let me just close that. Okay, so now what I want to know is whether this particular branching condition will be true or false. What I can do is I can select it and then I can say copy. Okay, and then add a new expression here. I can say paste. So now I want to see whether x less than 0 will be true or false. Well, it tells me it's true. So that means I can anticipate the following. Because this branching condition according to the current value for x is going to evaluate to true. That means I'm just going to execute whatever it is inside this particular branch, whereas I'm going to ignore or bypass the rest of the if statements, right? Remember, this is a single if statement, but only the very first satisfying branch will be executed. That's what we said before in the class and also in the tutorial. But now we can see that in action when we try to really slow down the execution in Eclipse. Exactly the same behavior. Okay? So now, as soon as I say step over here, because we already know x less than 0 will be true. So if I go that, you can say x is negative. Now, Well, after we say step over, what's going to happen? After we say step over, that means no lines left to be executed for this particular if branch. And are we going to bother with this branch? The answer is no, because only the very first satisfying branch will be executed, right? So now, as soon as we say step over here, you can see that basically we're now reaching the end of the if statement. It's still showing you line number 13, but we're still okay. We're still at the end of the this if branch over here. But you can see that x is negative has just been printed out. And then if I say step over again, you will see that we simply bypass the entire else branch, right? And then we'll say input.close over here. Okay, that's the first example I show you. You can see the debugger is very useful for you to find issues in your program, as we see the swap program, and also can show you exactly how your program has can behave in response to the different values. Okay, for the input. Let me try one more. If I simply just if I want to launch the debugger again for the same program, I can simply click on the bug button over here, and then I can click on that. I think maybe I should just stop it. That would be easier. Okay, how about we just terminate? Okay, you simply click on the square button here to terminate, and then you click on the bug button again. Okay, so now enter an integer. So now what should I enter? So now this time, let's say I want to trigger this particular branch to be executed. So I need to enter a number. Let's say I enter 8, for example. So as soon as I enter 8, it's going to just go to the breakpoint directly right before we try to execute line number 11, right? So now we want to know if this particular if branch will be executed. Let's see. If you go to variables, you can see x value is now 8, which makes sense. And then if you go to expressions, and the previous expression we did, x less than 0. Remember, x at the moment is simply just 8. 8 less than 0 will give you false. That means we can anticipate as soon as we say step over, because this particular branching condition is false, so the whole thing over here will be bypassed. Okay, so then I say step over, you can see we go directly to the else part, right? You can see this part is completely bypassed, right? And then what about this? What about here? And this one here, let me just show you what you can do. You can simply just, again, like what I did, you can simply select the whole branching conditions. You can say simply copy, and then add new expression over here. You can say right click and paste. So the whole branching condition here. And then we'll see that x being 8 is going to make this 5 less than or equal to x, ampersand, x less than or equal to 10 is going to make it true. That means we're really going to execute this particular branch, whereas we're going to bypass the rest of the if statement here, right? That's again, it's a very slow motion is really powerful for you to see exactly what's going on for your program. And let me show you one more. Sometimes you may actually want to really break it down, break the conjunction or disjunction into a simpler expression. Let me show you. What I meant was, you can see the left-hand side for the conjunction is 5 less than or equal to x. And that part is true, because 8 larger than or equal to 5 is true. And also x less than or equal to 10, that's also true. So now you got true and true is going to give you true. Okay, just as an illustration. You can definitely write whatever expression you feel like in order to help you understand what's going on with your program at the current moment. Okay, so now we know that this branching condition is actually going to be true. As soon as I say step over here, it's going to execute this particular branch, and then if I say step over again, it's going to print out x is in between 5 and 10. And then what do we expect to see next? It's going to bypass this particular else branch because it's a single if statement. Okay, if I say step over, okay, we simply go to line number 23, and this part is completely bypassed. Okay, hopefully you see the idea here. Okay, good. I think that would be it for this particular one. You know what? For completeness, I would like to show you just one more thing. Okay, let me just modify the program so that it becomes just slightly more complicated, and then I will summarize, and then we are done for this video. It's kind of long, but I will hope that you really see the value for debugger and try to use it as much as you can. It's really for your own sake. Okay, let's go back to Java perspective over here by clicking on J over here. So now I want to do another else if. So you can also see some else if. So now I can say else if over here. Okay, so over there we say that if x is in between 5 and 10, then we're going to print out something. What about, let's say, if x is in between, let's say, 15 and 20, for example. And then we're going to print out something. Okay, let me just modify that a little bit just to show you, so I can see that if, else if, etc. is in between 15 and 20. Okay, and over here we can actually, well, let me just x simply is not in that range. Okay, you can say x is not in, for example, between 5 and 10, and not in between 15 and 20, right? So x is not in these in either of these two intervals, right? So now I would like to show you exactly how the if. So again, this is still a single if statement. You got if, you got else if, you got else. But now we're gonna see exactly one satisfying branch will be executed. Let's see one. Okay. So now what I would do is, let's say we'll say debug again. But now let me speed it up. Actually, we still put line number 11. That's fine. So now I want to debug the same program. Click on that. So enter integer. Let's say I simply choose, let's say 17, right? So I will expect to see this particular branch to be executed. Let's say 17. 17. And then now I'm switched to the debug perspective over here. So now what do I expect to see over here, right? If you go to variables, you can see x is 17. And for the expressions, x less than 0 is going to give me false. So that means I'm going to bypass this particular branch. So now if I say step over, so now I'm here, right? So now what do I expect to see over here? If you see that, it's kind of interesting. 5 less than or equal to x as I previously enter is true, because 17 is larger than or equal to 5. However, x less than or equal to 10 is actually false. That means 17 is too large for the upper bound for this interval, right? So you've got true and false together is going to give you false. Okay, that is why we can expect this particular if branch will be bypassed, right? Only the branching condition is evaluated, but the body for this particular branch will be bypassed. So now if I say step over, you can see it was not executed. So now we go to evaluate the second one, right? So now for the second one, what's going to happen? Let's do exactly the same exercise. So now I can simply copy this guy here, the left operand. I can say copy, and then I can simply paste it over here. So now 15 less than or equal to x will be what? Simply true, because 17 is larger than or equal to 15. And then x larger than less than or equal to 20. Let me copy that too. Okay, and then let me paste it over here, right? If you want to type, you can feel free to type. And over here, 17 less than or equal to 20 is going to give me true. So now I can expect true and true is going to give me true. But for completeness, let me copy that. I can copy that expression over there and say add, and then I can say paste. So now I got true. So true and true will give me true. So that means this one is satisfied. So I will execute this branch over here. So if I say step over here, it's going to execute this branch. And then after this line, now I'm at the end of the branch, but you can see x is in between 15 and 20. It's now at the console. Now what's going to happen if I say step over? Because we say this particular branch was bypassed because the branching condition was false. This particular part will be executed because the branching condition is true. And only the first satisfying branch will be executed. So now the rest will just be bypassed. Let's see. So now if I say step over, you can see else part was bypassed. Okay, that's why we only got this single line printed out to the console. Okay, so it's a very complete trace for the various different branches for this if statement. Let's say if you go back to the example for compute text or compute BMI or for your rock paper scissors game, you can definitely apply this kind of technique to see if you believe that there is an issue with your program. Try to apply the breakpoints and debugger to really try to see what the issue is. As long as you can try to have a very good idea about how your program behave in a slow motion fashion using debugger, often case you can easily find a bug as long as you know what you're doing. Okay, let me recap and then we are done. So basically what we have said in this particular tutorial video is we want to say, since the basics we have taught you so far, especially nested if statement, will actually have your program become sometimes more complicated than you can manually manage. So that's why we want a way to really slow down the sequential composition of your program at the runtime so you can see exactly what's going on. So now, I just want to talk about conceptually, this is what's going to happen. Without the breakpoints, your program execution flow will just go like this. It will simply just go all the way from the top to the bottom, and then it will just print out whatever it is along the way without stopping. So you will only see your program output in the console. There's no way for you to see exactly what happened in the intermediate stages. The idea about breakpoint, let me just use a different color here. The idea about breakpoint is, let's say if I set a breakpoint over here, okay, that's when I set a breakpoint. Let's say like how we did it. What it would do is, now when I try to debug the program as a Java application, it's simply just going to execute but pause at this particular point. And then right before I try to execute this particular line, I can see exactly what the variables look like and also how the expressions look like, only for this particular line, right? So now if I find that this particular line looks okay, so I can definitely say step over. Okay, I can choose step over. So on the Eclipse, this is something you will see, right? Let me just show you again. The step over looks like this, right? Step over. Okay, it looks like this. Step over. Step over will allow me to say now, after this line, I can now step over. So that means I can go to the next line and then pause over there. And now I can see for this particular line, so how the variables, so now for this particular line, I can anticipate what's going to happen by looking at the variables and also the expressions. So the variables and the expression might change when you move from one line to another. So now, whenever you see the changes on the variables and expressions, you will be the person to judge whether the change is really as expected. If they are, you can keep going until you reach the point that you find that, oh, this change on the variables and expression is not exactly what I would expect. In that case, you found the issue for your program and fix it. Hopefully that will just fix the issue for your program. Okay, so for this tutorial video here, we didn't really help you develop any complicated program here, but we're showing you a very valuable technique for you to really analyze your program. Try to really practice yourself. If you got trouble, speak to me.